This is the first lecture of the last unit of our grade 11 physics course, and we are going to be learning about waves and sound. Our first lecture is on vibrations. So waves are disturbances that transfer energy over a distance. Water waves, sound waves, waves in a rope, earthquake waves, they all originate from objects that are vibrating. So for example, a water wave can result from the vibration caused by a boat rocking on the water, while sound waves originate from a vibrating tuning fork or a vibrating guitar string. In either case, the vibrating source supplies the energy that is transferred through the medium as a wave. So a wave is a disturbance that transfers energy through a medium, and all waves are caused by a vibration. The cyclical motion about an equilibrium point is called a vibration, and one complete vibration or oscillation is called a cycle. For example, windshield wipers, the pendulum in a clock, they both repeatedly move back and forth along a fixed path, and they result in a cyclical motion. So a vibration is cyclical motion about an equilibrium point, and a cycle is one complete vibration or oscillation. Oscillating waves caused by wind or earthquakes can threaten the structure of bridges if they are not properly designed. So engineers have developed different designs of bridges depending on local conditions, but no single design can take all possible wave frequencies into account. This is why we have different types of bridges. They have to be designed specifically for the environmental conditions of the area. And in some cases, you might have a bridge that needs to counteract high winds. In other cases, you'll have to have a bridge that's going to be designed in such a way that there will be a lot of vibration through the mechanical vibration of cars or large trucks driving on top of it. So these are things that have to be considered. This question says, a child is swinging on a swing with a constant amplitude of 1.2 meters. What total distance does the child move through horizontally in 3 cycles? So if we have this child and they're at the center of where the swing is, and then they move forward 1.2 meters, they move back 1.2 meters to their equilibrium position, they move back 1.2 meters away from the equilibrium position, and then forward again 1.2 meters back to the equilibrium position. That is one cycle. So a forward, back, and then back to equilibrium is a cycle. So that means that for each cycle, we have 1.2 meters times 4. That's the distance we travel in each cycle. We then multiply that by 3, and we have the distance traveled in 3 cycles, 14.4 meters. So if we have a vibration, but there is no medium for the energy from the vibration to travel through, we won't have a wave. So a medium is important for waves to transfer that energy from the vibration. A drum skin, for example, could be a medium through which a wave transfers. The Earth, we have earthquake waves, and these waves travel through the rocks in the Earth, but the Earth itself, the physical rocks and things that make up the Earth, are the medium through which earthquake waves can transmit energy that's caused by vibrations in the core of the Earth. So the thicker a material is, the faster a wave can travel. And the less dense a material is, the slower we have waves travel. If we look at the speed of sound, for example, sound will travel faster in solids than it will in liquids and than it will in gas. So in air, sound actually travels relatively slow compared to the speed of sound in water or the speed of sound in wood or glass, for example. A medium is a solid, liquid, or gas through which a vibration travels. The more rigid the medium, the faster the vibration travels. So there's three types of vibrations. One of them is a transverse vibration. This is when something vibrates perpendicular to its rest axis. You can think of this as a child on a swing. Another type of vibration is a longitudinal vibration. This is when we have vibration parallel to the rest axis. This is kind of like if you imagine a spring sort of vibrating in place, up and down. That would be a longitudinal vibration. And then lastly, we have the torsional vibration. This is when an object twists around a rest axis. So here, if you have a maybe a yo-yo or some sort of hanging kind of toy, and you spin it around and you watch it kind of unravel itself, that would be a torsional vibration. So these are the three types of vibrations: transverse, longitudinal, and torsional. So here's some questions, and we have to state the type of vibration. We have a diving board vibrates momentarily after a diver jumps off. So that diving board is going kind of up and down. It's vibrating perpendicular to the axis, so it is a transverse vibration. A woodpecker's beak pecks at a tree trunk. So this woodpecker would be going kind of in and out through this tree trunk. That would be a longitudinal. The vibration is parallel to the rest axis. The shock absorbers on a mountain bike vibrate as it travels over a rough trail. These again would be longitudinal. Shock absorbers would be they would vibrate in the direction of the rest axis, parallel to the rest axis. And then we have a car motor turns at 2,450 revolutions per minute. That would be a torsional vibration. Our last slide here, it says a pendulum swings with a regular period, so it is a useful device for measuring time. In fact, early drawings of a pendulum clock were developed by Galileo Galilei in 1641. His ideas for a pendulum clock were based on the observations of the regular period of vibration of a lamp hanging in a church in Pisa, Italy. He then postulated laboratory experiments to determine the factors that affected the period and frequency of a swinging pendulum.